Good morning and welcome. I think if I go to this first, yes. The future of broadcast networking, which is ever important, presently for broadcasters, radio, and TV, providing connectivity with costly high SLA levels is costly. And the one time it breaks, it's really, really bad and inconvenient. Today we're going to talk about the future of broadcast networking using multiple consumer-grade services, whether ISP, 5G, satellite, Starlink, in order to create a seamless connection using SD-WAN technology. So I'm Bud Williamson. I'm a broadcaster as well. I have a few stations up in the Hudson Valley, and I also provide consulting and broadcast engineering services, including to New York Public Radio, to Steve. Hence, I'm not only hearing about the pinch in cost, I'm experiencing it too, which is why this is, I think, a very timely presentation. Being at the forefront of technology, New York Public Radio and its CTO, Steve Schultes, along with Steve Uckerman, who is in the house here, and Jim Stagnito, started testing this technology over a year ago. So even though there's a cost factor in it, these guys did start this effort over a year ago, probably a year and a half ago. And you're going to hear about two pilot tests performed, one of which is still live. And since it's such a hot topic, and we know that there'll be questions, we will have a Q&A towards the end of the session here. So without further ado, Steve Schultes, if you don't know Steve, Chief Technology Officer at New York Public Radio. He oversees 6 technical divisions, including broadcast engineering, IT, media asset management, and streaming. I've got to look at the sheet because all I know is anytime I call him, he's there, and everything is under control with his team. Steve has also received the 2023 Radio World Excellence in Engineering Award for leadership and technical contributions. So Steve is the real deal, and his team as well with Jim and with Steve. And then we also have Vinay Purohit, who is the founder and CTO of CloudJuncxion. And this is the product you're going to see Seeker today and how that works. He's been leading SD-WAN innovations that transform military and DoD and commercial networking. So this isn't something that has just been created for broadcast. This is something that's in place right now and is able to be used in broadcast, whether it's radio or TV. So without further ado, let's move forward. Our speakers. And this describes today's session. I'm going to hand this off to Steve because Steve's going to talk about the 2 pilot programs that New York Public Radio has done, one for WQXR and then one for WNYC. So.
Thanks, Bud. Hi, everybody. That's okay. Hi. Well, Bud, you call me and you think things are under control, but they are. But that's really due to our staff members in the audience here: Jim Stagnito, Steve Uckerman, Irene Trudell is here. But yeah, hats off to this team. So just quickly, New York Public Radio, 30 seconds on what we are here. We have 7 FMs in the tri-state area. We have 1 AM in the tri-state area. So basically 8 transmitter sites, throw in a DR site down in Philly, and microwave relay sites plus our headquarters. We're looking at 10 static sites that we needed to connect together. And historically, we've always built our STL infrastructure on, self-healing loops, going back to, post 9/11 with Intraplex and different ways of creating like at least a low-level SD-WAN capability, just something to survive, break fix type things automatically. And then, so fast forward about 2 years ago, and I get, hats off to Steve Uckerman, our Assistant Director of Engineering, who knows Vinay from past work, long time ago, whatever. And Steve came to our engineering team and said, I've been working with Vinay, and he's got this product. It's basically from the Department of Defense. It's in the Army. And you have this incredible SD-WAN technology. 19-year-old servicemen in trenches in Afghanistan can operate this thing. It's simple and it's effective and it seems pretty cost effective. He said, I started looking at the data that they're using in the Army, and I said, well, what's so different about broadcast data? And there's no difference really. Plus, of course, we need the need for resiliency and driving costs lower. So he brought it to us and said, let's give it a try. And I guess you got your permission, right, Vinay? Okay.
Yes.
I'm asking now. But so this goes back to 2024. So we spent the entire year of 2024 basically studying the technology. We put it into place. I can click forward here so we get off this eye chart. I'll speak before I get to the proof of concepts. No one can read that, but basically, it's talking about reducing cost, meeting exacting transmission quality standards, low latency. But let me stop there for a second, because typically I don't talk at technical sessions about cost, but look, let's face it, everybody's talking about cost now, especially in public media, right? And so this was really one of the driving factors. You take 10 sites and you take high cost, high SLA telecom services, 5 nines of reliability, but you pay for that, right? I'm talking about traditional MPLS circuits, things like this. Emily's nodding her head. You've been living this for two decades. And it becomes unaffordable. The costs just keep going up when they should be going down. So we basically said, look, this technology opens the door to some real cost savings. So we're talking like 50% cost savings. And I don't usually talk about numbers, but let's put a number on this. We're like a monthly cost of an MPLS, traditional MPLS circuit for like 5 megabits is in New York City, it's about $900 a month. And now why don't we substitute that with an optimum consumer grade ISP for $90 a month? And then you multiply that by 10 sites and maybe 2 or 3 links per site. Now we're talking about some real cost savings, and God knows that's what we need these days. So let me fast forward here a little bit. But it's not only the transmitter sites. We realize, our remote crew, largely, Irene is part of that, and we have a very vibrant remote crew. We're in the field 40 events a year, basically. And Carnegie Hall is one of the main venues. We're there maybe, a baker's dozen, 14, 15 times a year. And we had the opportunity in summer of 2024. We said, why don't we try it at Carnegie? We had this opportunity of 6 live remotes every day for 6 days, 6 nights. It was the World Youth Orchestra festival. So we said, let's try it there. We basically loaded the software on a Raspberry Pi, shipped Steve Uckerman brought it to Carnegie. We had one back at the headquarters in our Soho studios. And we basically turned the engineers loose. We used a Telos Axia node. So we actually plugged it in for linear live wire audio back to the transmitter site, kept it linear through our Axia network. Out to our transmitter site, all live wire, and then basically broadcast it from there, in HD and analog, of course. And I remember the very first night, Steve brought it there. He brought it to the engineers. They tested it and they said, holy cow, this is great. We're not even gonna just, test it in the background. We're putting it on the air. So after Steve picked himself up from the floor, he said, you guys should really test it first. No, we put it on the air, and it stayed on the air for 6 nights. And the audio quality alone was just amazing. We saw packet hits. Vinay will talk about that a little bit. We saw packet hits, but in the Axia node, there was no packet loss. And actually, I think your metrics even show, besides the packet loss, but the overall, delivery was unaffected, correct?
Yeah. Yes, Steve. So I think what you're referring to is, both Verizon and Comcast ISPs,
yeah,
which were the links you were using. I think
right.
They were both occasionally taking hits, but the on-air product, the audio that was being broadcast was flawless.
Right.
Yeah.
And you had no complaints from listeners? I mean, WQXR with a discerning audience?
Yeah, no complaints whatsoever. And Master Control heard it. We all heard it. I mean, Jim Stagnito was listening on a laptop speaker, and he could even hear the difference, immediately with that. Our broadcast engineers in the cars, listening to it, could hear it on the HD radio. I heard it in my office that way. We took audio samples and we shipped it around. We said, all right, this is something that we really have to pay attention to. So, right. So, just a couple consumer ISPs from Carnegie Hall. We basically had the off-the-shelf codecs as a backup for that. It should have been the other way around. The CloudJuncxion should have been the backup, but we just went for it, right?
You saved some time there.
Yeah, absolutely. So, this talks a little bit about the test results, but we pretty much covered that already. But, again, focuses on uncompressed audio resiliently on low cost audio codecs. Vinay will talk a little bit about the algorithm in the devices. It's all data replication. And again, we saw, although we saw packet loss on the individual, ISPs, but the ultimate delivery was flawless. After that, we thought, okay, now we feel ready, for like 3 hours a night for 6 nights. Now we're ready to put it on the air for 24/7. And we basically installed it at our AM transmitter site in Kearney, New Jersey, across the river here. Same type of setup, Raspberry Pi at the transmitter site. We just moved the one from Carnegie out to Kearney, and then Raspberry Pi back at the headquarters. And again, and now that's, instead of, just 2 ISPs, we basically have we have a licensed microwave shop. We've got a consumer grade ISP. We had Starlink at the time. We were experimenting with that, which had a horrible SLA. Every night there's a software update, and it was out for like 5 to 10 minutes. And then a 5G codec. And that is actually, so that was basically fall of 2024. Now we're basically fall of 2025. We've been on it, since then. We just kept it in place. And it's performed flawlessly.
So you have Axia X nodes out at Kearney as well.
Correct.
That are feeding.
Correct.
Through the network.
Right.
Okay.
Yeah.
So Steve, you went from compressed audio to uncompressed audio.
Yes, compressed audio to uncompressed. Right.
So what was the compressed data rate like previously? And now you're doing about 2.5 megabits per link.
Yeah. So, like for example, at Carnegie, we were in the low 100s, 256 to 320 or so kilobits per second, which is actually pretty good from a compression algorithm. But again, we heard it immediately with the linear digital audio. And same thing at Kearney, a little more heavy compression there, maybe 128 kilobits, 250 kilobits. And we moved to uncompressed.
So can you talk about some of the metrics and the design of the system? This is, really what this can be anything. This is scalable, correct?
Yeah. So this is a generic picture here, showing 4 sites. You can see in the upper right corner is the studio site. So that's like for New York Public Radio, that would be the 160 Varick. And then the other 3 sites are either transmission sites or could be another, like a remote broadcast site itself. What this is showing is a diverse use of transports. And so up in the upper right corner, you have your studio site, you've got 2 ISP links, you may even have Starlink, for example. At the other sites, you can see it's a mix of Starlink, LTE, maybe point-to-point microwave. So any and all transport that you have available can be utilized for synthesizing essentially a virtualized pipe. And depending on the mode that you're operating in, you can either bond them together or you can use some higher resiliency modes for essentially hitless delivery. And that's what New York Public Radio was using. So at the end of the day, it's the product you put on the air that matters. And so what we noticed was that each of these links was subject to significant degradation from time to time. They were all taking hits. But from the audio metrics as to what was being put on the air, that looked flawless. And that's what ultimately matters. And these were all consumer grade links, not MPLS or other links with SLAs. So this is a generic diagram. You see in the middle, there is a cloud instance there. So that's another instance of our SDN software, and that's what allows you to use internet links in a plug-and-play manner. So it just takes out all the complexity. Don't have to worry about getting static public IPs. Your IP addresses can change, and this adapts to that automatically. So that's part of the set and forget operation. You want to configure this and let it run.
And this is something to get into because there's a GUI that you program this with. It isn't CLI.
Yes, so everything is GUI based. There are no CLI commands. Very simple to operate. All the feedback we get is you don't have to be a CCIE to operate this.
I think the GUI is the next slide if you advance that, Vinay. It's worth looking at this for a second.
That's I wasn't aware of this, but this is good.
Yeah.
So this is a snip of our UI. On the right, you see a conceptual representation of a network. So it's showing 4 sites. And on the top could be your studio site, and the other 3 could be transmission sites. And the lines between them represent, the different transports. And we built tunnels between them. And then on the left is, it's showing you the status of the tunnels between 2 sites. In this particular case, we're showing 4 different tunnels over Starlink, AT&T 5G, LTE, which is probably Verizon, and other AT&T link. And so you can substitute microwave or SATCOM links, even geostationary SATCOM links, for example. Man-made radios, which you don't use in broadcasting that much. But it's really simple to operate. A lot of self-healing features built in. So if you lose connectivity between 2 sites or direct connectivity, there is healing built in.
And there's testing built in. I like the testing feature as well. You can basically flood a certain segment, or you can cut it, and you can watch the algorithm fail over for the different.
Yes,
feeds.
a lot of features. We don't have time to talk about all that, but certainly ability to pump dummy traffic, if you like, for testing purposes. And also a lot of network healing or self-healing features built in. So if direct connectivity between 2 sites is lost, there is automatic rerouting through a 3rd site. So for example, if you lost your Starlink and your ISP connection, but you have a point-to-point microwave link with another site, this will immediately reroute it over that microwave link to get you back to the studio.
And what do the metrics look like from how this? Is that on the next slide? Oh, we're not there. Okay. We didn't put that in.
Well, I was going to say one last thing about this, that, we're talking about networking, and that's actually our next step to test, because now you've basically, if you got the links and you've created enough bandwidth, you've created a flat network to all your sites. It's no longer a STL path. It's really just another network node on your network, on your wide area network.
Yeah.
So this has all sorts of implications. Like if you're replicating your on-air delivery system at your DR site, you may not have to use a specific replication mode, but you can just basically have a formal copy constantly being created. It opens up a whole other world of networking for multiple sites.
Yes, so you can use your links, you can bond them together, or you can very selectively inject resilience for certain flows that are critical for your use cases. So in the world of broadcasting, that would be your audio feeds going from studio sites to transmission sites. But that same network could be carrying email and other traffic, which is maybe doesn't have to be hitless. So you have the ability to very surgically tailor or construct your system so that traffic that is critical will see the resilient delivery, hitless delivery, whichever term you want to use, while the rest will heal very quickly. It may not be hitless, but you have TCP applications kicking in with retransmissions, while things like audio where there is no retransmission. You lose a packet, you'll immediately hear the artifact. That's the one you want to protect. So you have a wide array of options available to be able to tailor the system.
And we're talking radio here, just audio, but video throughput. Have you tested this on, I'm putting you on the spot here. Have you tested this with a video feed as well?
Well, so this easily scales to gigabits.
Okay.
So while in the broadcasting world, typically your data rates are maybe a few megabits for uncompressed audio, but scaling this up to gigabits, I mean, obviously we need a little bit more CPU for that. So with the right hardware platform, you can easily scale this up to a very large number of sites. And also if you have, compressed video, ASI for feeds, for example, that's not a problem at all.
Let's open it up for questions. If there's anybody that's got a Paul.
Thanks for the presentation. From the business perspective, if somebody hearing this said, great, I'm ready, I'm going to go sign up for this. What's the business relationship from CloudJuncxion? Is this a monthly service fee, or how does it work on the business side?
Yes, so it is a subscription model, but we are aware of the price pressures. So obviously the pricing for the broadcasting market and the feature sets are tailored appropriately. So happy to have that discussion. And Brian standing behind at the back there would be the right person for
Brian Wave. Okay.
And would that price scale by market size, by network size?
Yes, so number of sites and the throughput. So for broadcasting, for example, if you're looking to do a few megabits, that's one price point. If you're looking to do gigabits, that's another price point. And number of sites matters as well.
Thank you.
Okay. Questions? Any other? No more questions. No. Bert? Oh, I'm sorry. I missed you.
It's Greg.
Hi. Can you talk about the security aspects of the solution?
Yeah. So, what we did not mention, is this creates a secure, VPN overlay. Can create layer 2 VPNs, layer 3 VPNs. All the, tunnels are AES 256 encrypted. We use PKI for authentication. So a lot of security features built in.
Okay. We get a mic for Bert, and David, you'll be next.
So is this basically a fixed location? If you needed to do, say, an off-the-cuff remote broadcast somewhere, how quickly would it take to set one up?
I think Steve can talk to this because he's done it.
Yeah, I mean, for Carnegie, I mean, that's a fixed venue, right? And they had ISPs there, but we are experimenting with it now. We're in the field, every month, usually for news remotes and things like that. And we just pop up at different venues and things. And we're using 5G basically, different kind of, bonded 5G or different 5G carriers coming in, and then we'll basically put it into we have a mini computer, a hardened mini computer running Seeker, and we've been experimenting with that. I don't think we've taken it out in the field yet, except for Carnegie, but that's our very next step.
But you touched on something. You had set up the Raspberry Pis, but there's an appliance for this as well.
Yeah, so our product is mainly software, and you can run it on a range of platforms, all the way from Raspberry Pis to big servers, VMs, containers.
Questions?
Hi. Why did you select Seeker over other SD-WAN options?
We've been trying different SD-WAN, like I said, ever since 9/11, and we put in different, our interplex things and every codec that you buy now has some sort of SD-WAN sort of capability in it. And then we were also using like our firewall and for SD-WAN capability. But this had basically, first of all, it was much easier to train. We didn't talk about training, but we had 1 day of training for a group of about, I don't know, Stag, what was it? six engineers or so. So we were able to basically learn this in one day. Rather than, look at try to do this on a Cisco or a Fortinet, SD-WAN, appliance. It was easier to tackle. And honestly, the feature set is just so much more, resilient. I mean, there's, you can base your priority on things like on jitter, on latency, on throughput. And the failover capability is just so amazing for all those different metrics. So I think that's kind of the summary of that, David.
How many people have a use for this product? I know, Jeff, you do. Yep. Okay. I know you do, Bert. This would be perfect for you.
So, just one comment, if I may. As broadcasters, you're probably used to deploying audio codecs that do their own resilience.
Yeah.
With this, the resilience piece now is offloaded to the SD-WAN component, and your sources, whether they're audio sources, video sources, no longer have to do the dual NIC or their own resilience management. This offloads all that. So your application stacks become much simpler because now you don't have to worry about the networking complexity. That's handled by Seeker for you. I just wanted to mention that.
Good point.
So anybody that has an interest?
Any last comments?
We are in 2D01. So if you'd like to get a demo or talk more details, that's where we're located.
Which direction is that from here? It's downstairs?
Downstairs.
Downstairs, one level. Two.
Yeah, I invite people to talk to Vinay, about this. He can go really deep into the program. It's pretty amazing.
And I'm going to call out Steve Uckerman and talk to him about it too, because he's been deep on this and he understands this technology because he's a smart guy.
100%.
So, okay.
Thanks, everybody.
Thank you.
Thank you.
Thanks.